Hello, Mr. Geiselhart here, and we're going to take a look at solving a triangle using the law of sines when there might be two possible triangles. First thing you need to do is decide, is there two triangles or is there only one triangle possible with the given diagram? In order for there to be two triangles, there's three conditions that must be met. The first one is that you must have two sides in the non-included angle. So usually we call that side angle. What I mean by unincluded angle is that the angle given is not the angle in between the two sides that's given. It's outside of that. So this case is side angle. The next thing is that the included angle must be an acute angle. So the angle that we're given here is acute, it's less than 90 degrees, and the last is that the opposite side of the angle given must be shorter than the side that is adjacent. So this triangle satisfies all three of those cases. When I want to find all the missing sides and angles, I'm just going to label each thing. So I'm going to call the missing side down here X, I'll call the missing angle Y, and I'll call this missing angle Z. So the first thing I need to do is find angle Z, and I can do that just using the law of sines how I normally do. So the sine of 49 over 14 equals the sine of 17 over Z. So if we write it out, it'll look something like this. The sine of 14, whoops, let me back up here just a second. The sine of 49 over 14 is equal to the sine of Z over 17. When you cross multiply, you'll end up with 17 times the sine of 49 equals 14 times the sine of Z. Divide by 14, and you get the sine of Z is equal to that. Now, in order to solve for the angle Z, that's where you have to do the inverse sine of that whole part there. When you do the inverse sine of that, you end up with Z is equal to 66.4, and I'm just rounding to the nearest tenth there. Once you know angle Z is 66.4, we can find angle Y because there's 180 degrees in a triangle. So if I subtract 49 degrees and subtract 66.4 degrees, that will give me the measure of angle Y, which is 64.6, and that's equal to Y. So now I have all three angles. The last thing I need to do then is just find side X. To find side X, I'm going to use the law of sines again. So I do the sine of 49 over 14 is equal to the sine of 64.6 over X. And again, I'm going to cross multiply, and I get X times the sine of 49 is equal to 14 times the sine of 64.6. Divide by the sine of 49, divide by the sine of 49, and we get that X is equal to 16.76. So that's the first triangle. Now, we said that there's two possible triangles here. The second triangle will be created when I take this side of the triangle and kind of slide it over or rotate it in this direction. When I do that, I'll have another triangle that looks now like this. So my first triangle looks like this, and then my second one is this smaller triangle here. Now, if I move that side, it's still 14, so I have an isosceles triangle. So if I know the measure of this angle, which we do from the previous problem is 66.4, then this angle also has to be 66.4 because in an isosceles triangle, the base angles are equal. So once again, if I were to label these and call this angle up here Y, this side X, and this angle Z, I can solve for Z simply by taking 180 and subtracting 66.4. And I see now that I messed that up there, and I'm going to erase that, and I'm going to put 66.4 there. So I have 180 minus 66.4, and that's going to give me 113.6. If I know Z is 113.6, I can find Y by doing 180 minus 49 minus 113.6. And when I do that, I'm going to end up with 17.4. So I know Y is 17.4. Then the last thing I have to do is find X, and I'm going to use the law of sines to do that. So I'm going to start off by saying the sine of 49 over its opposite side, which is 14, is equal to the sine of 17.4, which is y, which is opposite of side x, over x. When I cross multiply, I'm going to have 14 times the sine of 17.4 is equal to x times the sine of 49. Divide by the sine of 49, divide by the sine of 49, and I end up with x is equal to 5.54. So that's how you do the law of sines when there are two triangles that are possible.